In this lesson, we're working in lesson 2.1. We're going to be describing and graphing transformations of quadratic functions. Now, we've already done transformations of functions before, so a lot of this should be review. But one thing we do want to kind of start out with is looking at this form of a quadratic function called vertex form. I know this is quadratic because you can tell that there's an exponent of 2 here. And remember, when we're working with functions, this number out front, this will help us know whether a vertical stretch or shrink is taking place. If a is negative, then you know that there will be a reflection over the x-axis. This value inside the function, inside the parentheses, remember this will indicate a horizontal translation. And a value being added or subtracted outside the function, that indicates a vertical translation. And then something else that we want to take note of is the vertex of a parabola. So if you have your parabola, the minimum or the maximum of your parabola is called the vertex. And you'll be able to tell where the vertex is located by looking at the vertex form of the quadratic function. And you'll notice that the vertex will always be located at the point H, K. And so you can look at your quadratic function to find where the vertex should be. Okay. All right, so we're going to work through number 2 in lesson 2.1 in the extra practice section. In number 2, we're going to describe the transformation of f of x equals x squared represented by g. Okay, so we're wondering what happened to the parent function to get to our new function g. Okay. So I notice that we are subtracting 1 inside the parentheses, inside the function. So we know that is a horizontal translation. And remember, it's kind of opposite direction you would think. So minus 1 means it's going to be 1 to the right. We're subtracting 3 outside the function, so that is a vertical translation. 3 down. So one way to graph this is we can graph the parent function. So let's start by graphing the parent function f of x equals x squared. So we should have a pretty good idea of what this looks like. We've graphed it quite a bit. The vertex is down here at 0, 0. Right, if we were to think of where this function is at other points at an x value of 1, the y value will be 1, and it's symmetrical, right? So it will have a point at negative 1, 1 as well. At 2, an x value of 2, the y value is 4, and so on. Okay, so I'm just going to use those to create my parent function. Okay, so this is f of x right here. This is my parent. Now, you could create a table of x and y values to plot this. But I want us to think about how could we plot this by using transformations. So like we said, we know that g of x, all it's going to be is our parent function, but shifted 1 right and 3 down. So to get g of x, I can take points that are on my parent function and simply shift them 1 right and 3 down. So that's what I'm going to do. I'll take this point, 0, 0, and go 1 right and 3 down. Just keep in mind this counts by 2s. 1 right and 3 down. 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 And so my purple graph here is g of x. Now, a nice way to check, just to make sure you've done things correctly. Remember we said the vertex is going to be located at HK, and just keep in mind this is minus H here. So if we look at our function, if I look at this value and this value, my vertex should be located at +1, -3. And if I look at my purple graph, that is where the vertex is located. Right. Okay. Number 3. Describe the transformation and graph the function. Okay. So one thing I notice is we're adding 9 inside the function. I know that's a horizontal translation. And remember, it's opposite the direction you would think. So +9 means we're going to be going left 9. I also notice that there is a negative in front. So remember, when you have a negative in front, that means there's going to be a reflection. And that, since it's outside the function, it's a reflection across the x-axis. Okay. All right, so I'm going to go ahead and graph this function. Again, you could create a table and plot this new function. But again, I want to think about it as transforming my parent function using the translation and the reflection. So I'm first going to go ahead and plot the parent function. It's at 0, 0. This time this counts by threes. So let's see. If I were to plug 3 in here for x, I'd get a y value of 9. Okay. So I know it's going to look something like this. Okay. So here's my parent function, f of x equals x squared. I'm going to take this parent function and I'm going to do a horizontal translation, 9 to the left, and then I'm going to take that point and reflect it across the x-axis. Okay. So I'll start with my vertex here. I'm going to go left 9. 3, 6, 9. There's my vertex. If I were to reflect this across the x-axis, it's not actually going to move at all because it's right on the x-axis. So it should stay right there. I'm going to go ahead and take this point and move it 9 to the left. 3, 6, 9. Now from here, I'm going to reflect it across the x-axis. So keep in mind, here's our x-axis. If I reflect it, instead of being 9 units above the x-axis, it will be 9 units below. So I'm going to take this, and instead of 9 above, I'm going to go 9 units below the x-axis. And that should be where that new point is located. Now my other point here that I had on my parent function, I'll move 9 left and then reflect it across the x-axis. 3, 6, 9. Okay, so this is 9 above. So it needs to be 9 below. And then I'm going to go ahead and create that new function g of x. Notice how the vertex here is located at -9, 0. And if I look at vertex form to see by looking at the function with the vertexes, right, my h is -9, right? So it's located at -9, and there is no k value. It's like it's +0, right? So k is 0. So from the equation, I would expect that the vertex is at -9, 0, and it is. Okay, the last one that we're going to do is example 5. So first, we're going to describe the transformation. Okay. I notice that outside the function, so outside parentheses, we're subtracting 6. That's a translation 6 down. And we're also multiplying by 1/3 out front. So A, our A value, if we're thinking about what we had in vertex form, that's going to give us a vertical shrink, right? Because A is equal to 1/3. So that's less than 1, right? So a vertical shrink by a factor of 1/3. Okay. Now, when we're doing vertical shrinks, I recommend making a table in order to graph this function. So I'm just going to go ahead and first graph the parent function, just so we can compare it when we're done. So 2, 4, okay. Here's our parent function, f of x. Now I'm going to graph g of x by using a table. So I'm going to create an xy table. I'll pick, I'll pick -2, -1, 0, 1, and 2 for my x coordinates. I'm going to plug in -2 in for x. I'll show my work over here. So I'm going to plug in -2 in for x. Make sure you put that inside parentheses. Okay. So I'm going to do 1/3 times -2 squared minus 6. And I get a decimal, that's okay. I'm going to get -4.7 about. I'll do the same thing for my x value of -1. 1/3 times -1 squared minus 6. -5.7. Do the same thing with 0. Plug in 0. I'm going to get -6 there. When you plug in 1 and 2, you're going to get the same values as -1 and -2. Okay. So I'm just going to do my best to graph these points. Okay. I'm going to graph a point at 0, -6, which I would expect, right? Because I said it's going to shift 6 down. So there's that vertex shifting down 6. -1, -5.7, -1, -5.7. So somewhere, if this is -6, it's going to be somewhere around here. It's going to be symmetrical. -2, -4.7, -2, -4.7. So almost 5. So then I'll go ahead and connect my points. Okay. And you can tell that a vertical shrink has happened. We've taken this parent function, we've kind of like smushed it down towards the x-axis. It's gotten wider.